In 8.1, we looked at finding the confidence interval for a population mean when the standard deviation for the population was known. Now, if we don't know the population mean, would we really know the population standard deviation? It's very unlikely that we would know it. So that in normal practice is very unlikely. Therefore, we would have to use the sample standard deviation. Also, that means we would not be able to use a z-score. When the population standard deviation is unknown, we will be using what is called a t distribution. Now, properties of a t distribution, it's similar to a z, it's symmetrical, but it is more spread out, it's wider. And the t-scores are based on what are called degrees of freedom. Now, degrees of freedom are in your sample size minus 1. Now, you can use a table to find your t-score. And I'll show you what that table looks like. We'll also learn how to do this with the calculator. So on a table, which I believe I've posted online, your degrees of freedom are listed on the left. Your confidence intervals, the most popular ones, are listed on the right. And the t-scores are given here. Now, it doesn't give you every single degree of freedom. After it gets past 30, 32, 34, 36, 38, 40, then it jumps to 45. So there's a few missing in there. If the degree of freedom that you're looking for is not listed, use the next smaller one. Now, the assumptions we have to make, first of all, it's got to be random. Want to have a random sample, and we either have to be large enough or know that we're normal. If the sample size is too small, we can look at the graph to see if it's normal, no outliers, not too skewed, to see if it's approximately normal. So, to construct a confidence interval, we're going to check our assumptions. Are we random? Are we sample size big enough? We're going to compute the sample mean and the sample standard deviation, unless it's given to us. We'll find the degrees of freedom and the critical value. Compute the standard error, which is taking that standard deviation divided by the square root of n. Multiply it by the critical value, just like before, to get that margin of error, that error value. And use the point estimate plus or minus that critical value times the error. So, same process, it's just a t-score, not a z-score. So let's say we have a 2-lane highway with a posted speed limit of 45 miles per hour. It is located just outside a small 40-home subdivision. The residents of the neighborhood are concerned that the speeds of cars on the highway is excessive and want an estimate of the population mean speed of the cars on the highway. The Department of Transportation estimates that 2,400 cars travel on the highway between the hours of 9 a.m. and 3 p.m. The residents decide to measure the speed of 12 cars on the highway during non-peak times. The 12 cars will be selected using a simple random. So these 12 cars are my sample. N is 12. Using a simple random sample, yay, by determining 12 numbers between 1 and 2,400 and measuring the speed of those cars using a radar gun. The data below shows the speed of those 12 randomly selected cars, and we are going to construct a 90% confidence interval about the population mean. So, our sample size is less than 30. So I need to see if this is going to be fairly normally distributed. So what I'm going to do is I'm going to go in and put my data in L1. So 57.4, 56.1, 70.3, 65.6, 44.2, 58.6. Hopefully I'm not messing up anywhere. Now, to see if this is normally distributed, I can do it a couple of ways. I'm going to go to the stat plot feature, and I'm going to turn it on. So I'm going to turn on the first one on, and I can look at a histogram. I can look at a box plot. This first one with the box plot shows any outliers, so that might be a good one to use. I'm going to try that one. Now I need to make sure there's nothing in Y1, and I did have some weird stuff going on in my calculator. So I'm going to go back to Y1 and clear it out. Now since I was going to be doing a stat plot, we're going to go to zoom, and number 9 is zoom stat. I don't see any outliers. That's good. Let's go back in and change this to be a histogram. It's a little bit skewed, but for our sake, we're going to say it's fairly normal. Fairly normal. No outliers. Now we need the sample mean and the standard deviation. So that was under, stat, one variable stats. Now I did not have a frequency list, so I'm going to clear that out. It gives me, my mean is 59.6, and the SX is my sample standard deviation. Find the degrees of freedom. The degrees of freedom is n minus 1, n minus 1. So it's 12 minus 1, that's 11. And now I'm going to look at my chart. So I'm going to do this one by hand. We want 90% confidence, degrees of freedom 11, and 90%. 1.796. So the critical value for T is 1.796. So to get our standard error, our margin of error, I'm sorry, we're going to take the 1.796 times 6.96 divided by the square root of our sample size. The margin of error is 1.796 times 6.96 divided by the square root of 12, and that's 3.608. And this should be an X bar. I don't know why my computer, Word just doesn't like me sometimes. So we're taking 59.6 plus or minus 3.608. So to get the lower boundary, we'd subtract. And the upper boundary, we'd add. So what does that mean? It means I am 90% confident that the average speed of all cars on that highway is between 55.992 and 63.208 miles per hour. Now this can also be done in the TI. It's under T interval. Well, how neat. The other one was under Z interval. This is under T interval. So I'm going to go down to T interval. And actually I had my data in there. So data was in L1. 0.90. Calculate. It says it's between, it rounded up a little bit, 56.01 and 63.223. It's probably more accurate than what I did because I rounded a little bit here and there. It was a little more accurate. Okay, example 2. And we can actually use the calculator now. A random sample of 35 movies. Yay! Random, and it's over 30. Oh, awesome. N is over 30. N is 35. Check. Made in the last 10 years had an average. So X bar is 125.2 and the standard deviation is 20.4. And we're using a confidence interval of 95. Now I could still use this chart if you wanted to. If N is 35, then my degree of freedom would be 34. I would look for 34. Then I would go across to find the confidence interval at the top of 95. And I would find the T value that way. In the calculator, you would just go to T interval. Now this time, I'm not going to use data, I'm going to use stats because I'm given the statistics. We're using 0.95 and it tells me it's from 118.19 to 132.21. As of January 2017, there have been 5 movies released in the Bourne film series, and their mean length is 119.8 minutes. Someone claims that the mean length of Bourne movies is actually greater than the mean length of all Hollywood movies. Does the confidence interval contradict this claim? Yes. The average length of all, I'm 95% confident the average length of all Hollywood movies is between 118 and 132 minutes. Now, I should have brought this up when we had the the problem where we had the issue with our data being less than 30. T-scores are also used when sample sizes are less than 30. We really can use a T interval and feel a little bit more comfortable with it. So we can use it with each of these other examples. I did not have these done previously, so let me grab my copy here. Whoops, it's not that copy. I have written at the top of my page, fix for next year, and I forgot to fix a whole bunch of these for next year. So I apologize for that. We can only use the t-scores for sample sizes less than 30 if we know that they're normally distributed. I should make that note. So if we know that it's normally distributed, sample sizes less than 30, this is the best way to go. So it says that construct a 95% confidence interval. We have 10 students. The average amount of sleep is 7.1. Standard deviation is 0.78. We're just going to do one more example using the calculator. Now, I will be working on getting example of using, how many people? It was 10 people. Using the NumWorks app, or I will post another website that you can use, or you can Google confidence interval calculator, because if you don't have a TI, I'm fine with you using another source, but I'm just have not learned how to use the NumWorks app to do these. I will find out how to do them and let y'all know. But that's how to do a t-interval.